Okay, boys and girls, so 13, when 2047 is divided by 9, what is the remainder? So they want us to divide this dividend by the divisor 9, and it even gives us that keyword divide, and it wants to find the remainder. So remember, our remainder is our leftover. Okay, so I'm going to draw my box. Because I have 4 digits in this number, I have 4 sections. So 1, 2, 3, 4. I'm going to put my number inside. So I have 2, 0, 4, 7. And I'm going to put my divisor, which is my 9, on the side. Put my steps. I'll put them over here. So divide, multiply, subtract, bring up, repeat. Okay, so 9 can go into 2 0 times. 9 times 0 is 0. I tried dividing, and I multiplied. 2 minus 0 is 2, so I subtracted. I'm going to bring up. I'm going to do rover start over, so I'm going to go all the way back to divide. 9 can go into 20 2 times. 9 times 2 is 18. I'm going to subtract. So this, I'm going to regroup. This will become a 1. 0 will become a 10. So 8, 9, 10. I get a 8, 9. I get a 2. I subtracted. Now I'm going to bring up. Okay, so 9, I did bring up. So I'm going to do rover start over. 9 can go into 24. So in case we don't know, 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. So 27 is too big, so I have to do 2 still. So 2. Okay, so I divided. 9 times 2 again is 18. I'm going to subtract. So the 2 becomes a 1. The 4 becomes a 14. So 8, 9, 10, 11, 12, 13, 14. I get a 6. Okay. I subtracted. Now I'm going to bring up my 6. And I'm going to do rover start over. So I ask myself, how many times can 9 go into 67? So again, if you're having trouble and you don't have your multiplication chart, I would just write down the multiples. So 9 times 4, 36. 9 times 5, 45. 9 times 6, 54. 9 times 7, 63. 9 times 8 is 72. Okay, so 72 is too big, so I can do 63. So I can put a 7 here. And, oops. Okay, I put a 7 there. I divided, so now I'm going to multiply. 9 times 7 is 63. And now I'm going to subtract. 7 minus 3 is 4. So that means my answer is 2,227 with the remainder of 4. But they only want the remainder, so my answer is C. Okay. Next problem says a computer cost $2,599 in 2018. In 2017, the computer cost $466 less than it did in 2018. In 2016, the computer cost $562 less than it did in 2017. Which equation can be used to find C, the cost of the computer in 2016? So I'm going to do my cube. Circle my important numbers. 2,599, 2018, 2017, 466, 2018, 2016, 562, 2017, and 2016. I'm going to underline my question. Which equation can be used to find C, the cost of the computer in 2016? Box in my keywords. So which equation and we're looking for the computer in 2016, the cost of it. Less is a keyword, and we have less again. Okay, I should box in less than. So less than tells me that I'm probably going to be subtracting, but let's just see. So I'm gonna work this problem out so I can see, well, how am I doing it? So I know that a computer costs $2,599 in 2018. So I'm gonna put that here. $2,599, and this is in 2018. Okay. In 2017, the computer cost $466 less than it did in 2018. So that less than is telling me I'm going to subtract, and I'm going to subtract 466. And when I subtract it, 9 minus 6 is 3. 3 again. 5 minus 4 is 1, 2. So I know that in 2017, the computer costed $2,133. Okay, that's my first step. Then it says, in 2016, the computer cost $516 less than it did in 2017. So I already know 2017, it's $2,133. And I'll put this as 2017. This is my second step. It says that it was $562 less in 2016. So I'm going to subtract again, less than. I'm going to do 562. And when I subtract, I get 1. This becomes a 0. This becomes a 13. 6, 7, 8, 9, 10, 11, 12, 13. This becomes a 1. This becomes a 10. 10 minus 5 is 5. Bring down my 1. So now I know the cost of 2016. Okay. So I found all of them. I knew 2018, I found 2017, and I found 2016. Okay, so how did I do that? Which equation can be used to find C, the cost of the computer in 2016, which is right here? How did I do that? Well, I subtracted everything. So let me go through my answers. Can't be A because they added, I didn't add. Can't be B because they added again, I didn't add. I'm between C and D. So C says they subtracted 2,599 minus 466. I did that, but I also had to do the second step. Okay, so it's not C. They're missing my second step. And I can just put here missing second step. D says they subtracted. That was my first step. And then they subtracted again. This was my second step. So my answer is D. Okay, 15 says, at a grocery store, Gina bought 23 bananas, 5 apples, and 12 oranges. Which equation can be used to find X, the total number of pieces of fruit Gina bought? So I'm going to do my cube, circle my important numbers, 23 bananas, 5 apples, 12 oranges. Underline my question, which equation can be used to find X, the total number of pieces of fruit Gina bought? Box in my keywords, which equation, total number, and it's looking for fruit. Okay, so total number tells me that I might add. Okay, and we're looking for equation to find the fruit. So I know that she got 23 bananas. And then she got 5 apples. And she got 12 oranges. Those are all the fruits that she got. And if I need to find the total number, I would add all of them. Okay. So 5, 6, 7, 8, 9. So 5, 6, 7, 8, 9, 10. 2, 3, 4. So this is our total, 40 total fruits. So the way I figured that out is I added them. Okay, so I added 23, 5, and 12. Which one says that? A says I subtracted. Nowhere did I subtract. B might be it. C says I multiplied. There's no reason for me to be multiplying in this problem. And D says I subtract. Didn't subtract. My answer is B. Okay. 16 says the first four values in a number pattern are shown. 9, 18, 27, 36. Which table correctly represents the relationship between a number's position in the pattern and the number's value? So I'm going to do my cubes, circle my important numbers, which are all of these. Underline my question, which table correctly represents the relationship between a number's position in the pattern and the number's value? Box in my keywords. So value and correctly represents the number's positions and the number's value. So it says here the first four values. It's telling me already that these numbers are my values. So I'm going to write that here so I can remember it. My values are 9, 18, 27, 36. I want to go do process of elimination, and I want to see which ones do not have this as a value, okay? So this one has it. This one does not have it. So I already know B is not it. C has it and D has it, okay? Now I want to go look and see the positions, okay? Your position numbers cannot be the same as your value numbers. So I'm going to tell you what I mean. In A, if you notice the positions are the same as the value, that is not right. They can never be the same. Okay, so not A. If I look at C, same thing. They're the same as the values. That's not right. So it's not C. My only answer could be D, but let's just make sure that it's right. So it has 9, 18, 27, 36. If I use the rule, so this is my rule is times 9. If I use my rule, does it work? 1 times 9 is 9. 2 times 9 is 18. 3 times 9 is 27. 4 times 9 is 36. That works out perfectly. So my answer is D. Okay, always check to see, always check to see if the rule works with everything before you make it your answer. And always look at your positions and your values. Okay, 17 says the table shows a relationship between the input numbers and the output numbers generated by a number machine. Which number machine shows the same relationship as the one shown in the table? Okay, so I'm just going to highlight this whole table because it's very important. And they're giving us our input numbers and our output numbers. Okay, we learned about that, our input or output. When we learned about input and output, we always said there has to be a rule. I need to find a rule, okay? My rule has to work with all of the numbers, okay? And if you look down here, these numbers they're giving me, these are my rules. So I need to see which rule works for all of them, okay? I will start with A. So in A, they're telling me that if I get my input number, which is 1, and I add it to 39, then I will get my output, which is 40. So let's see, 1 plus 39, 40. It works for this one, but does it work for all of them? So let's see. 2 plus 39 is 41, 39, 40, 41. 3 plus 39, so 39, 38, 39, 40, 41, 42, that works. Okay, let's see. 4 plus 39, so 39, 40, 41, 42, 43, that works. So A might be my answer, but I need to check all of them. Okay, so I'm just going to put a little line here. For B, they're telling me that I'm multiplying. So let's try it out. 1 times 40 does give me 40, okay? What about 2 times 40? This one I have to do on the side. So 40, well actually no, I could just do my eggs. So I can move my egg, and 4 times 2 is 8. Nope, I did not get 41, so it's not B. Okay, let's do C. It's doing plus 1. So 1 plus 1, I get 2. Nope, I didn't get 40, so it's not C. Let's do D. Plus 40. So 1 plus 40 is 41. Nope, I was looking for 40. So my answer is A. And it worked for all of them. Okay, so my rule I can say is plus 39. Okay, 18. The rule plus 6 is used to show the relationship between the position of a number in a pattern and the value of that number. Which table shows this relationship? So they're telling me that my rule is plus 6. Okay, so I already know that. I can put that somewhere here because that's very important. Rule is plus 6. And we're looking for the relationship between the position of a number and the value of that number. So again, remember I talked about how the position and the values cannot be the same. So A are not the same. Okay. B is the same. They both have 6 in the position and value. So nope, not it. Okay, C is not the same, so that's good. And D is not the same, that's good. Okay. So now I want to see which ones are using the rule plus 6. Okay. So if I look here, A is using 6 plus 1, 6 plus 2, 6 plus 3, 6 plus 4. Okay, they have it to where they don't have a plus sign in front of the 6. They have it in front of 1, 2, 3, and 4. So that's a little bit weird to me. Okay, so I'm going to come back to that one. For C, they have the plus in front of the 6. So they have plus 1 plus 6, 2 plus 6, 3 plus 6, 4 plus 6. So that one looks better than A. For D, they don't even have that rule here. There's no plus 6 anywhere. So it's definitely not D. So now I'm stuck between A and C. This is how you find out which one's the answer. If you look at A, all of the position numbers are the same. That's not right. It should not look like that. Okay? That is wrong. They should never be the same number. Your answer is C. They have different numbers for the position, different numbers for the value, and they have a plus 6 for each of them. Okay?